Thank you, Petra, for your warm words. I'm very grateful to be here. For those of you having some lunch or snack, bon appetit. For those who are listening, keep listening because it's gonna be different than the previous presentation. I'm going to speak a bit about biology and photography, of course, with my presentation non-destructive, fast, ultraviolet application of UV photography in ecology, taxonomy, and evolutionary biology. Well, I've put here so many logos just not to impress you, but rather express thanks to these institutions like Národní Museum or Natural Museum in London or Naturhistorischen Museum in Wien or Tartu Museum. So, what are the main objectives of this presentation? We definitely start with the ultraviolet photography. What are the methods? And also we do have 3 cases of our UV photography stuff with 3 different species. In case if it's too biological focus, let me know and I will try to modify it, but hopefully you will understand all the terms. Why we are so interested in UV pictures and in UV patterning, that there are two reasons. Humans are somehow handicapped because we are not able to sense UV. So we rely on the assistance of technology, and there are 2 main possibilities like UV photography and also UV spectrophotometry. I'm gonna speak about the UV photography. And why butterflies? Basically because they are beautiful, they are colorful, and they are flat, and they are studied a lot, but not in the UV, as you will see. So first, ultraviolet reflected photographs of plants and butterflies were taken using a pinhole camera. That makes sense, right? In early 20s or 30s, 1920s, of course. And only later, around the year 1950, classical film photography was employed to produce UV photographs. But this procedure was complicated and very time consuming. Compared to that, the development of digital photography offered a much quicker and cost-effective way of producing images. However, it's not that easy as you would think. UV photography has got some kind of specific challenges regarding the necessary technical equipment which need to be overcome. First, you need to consider some camera which might be sensitive to UV, of course, because all the regular cameras are not sensitive to UV. There are possibility to adapt your chipsets to the sensitivity, but it's a bit complicated. Our Fuji ES Pro, which we used in the previous papers and in previous research, the sensitivity spectrum spanning from 330 nanometers to 900, which works perfectly fine for our biological objects. Furthermore, of course, the camera needs to be equipped with uncoated UV transmitting, or it's much better to use some quartz non-distorting lens. We have used old Russian 70 or 80 years old lens, which works perfectly fine. And of course, you need to somehow filter the visible light and the infrared light just to get the light what you need. So you need the set of filters. And finally, there is artificial source of the UV light because it's not enough to get the amount of the UV light from the sun. And also, it's definitely to express that we are using mainly the museum specimens. We are not dealing with live butterflies. So we need to use some kind of source of the light, which is mercury lamp or flashlights, or even today some kind of LED light specially adapted to the UV spectra. And as you basically are all used to have some kind of standardization of these pictures. So case number one, it's this nice tropical South American butterfly. It's like 20-25 centimeters wingspan, kind of nice, rare butterfly. The thing is here that the coloration of some species of butterflies looks very similar in visible light. However, it proves to be very distinct in UV spectra. So UV patterns could serve as some kind of reproduction isolation mechanism. So they could act as some kind of taxonomical characters, possibly. That's why we used this South American Eryphanes volvizora. Subspecies were previously distinguished by small differences in morphology, which are very complicated to study. So even though we have around 40 specimens, using UV photography, we demonstrated that the shape and position of UV structures are distinct enough to enable relatively easy differentiation between subspecies or even species of this complicated species. This study was not published yet, but we cooperate with our colleague from Natural Museum in London. And as you can see here, using UV photograph data and methods of geometric morphometric, we found specific configuration of UV pattern in various species of this tropical butterfly. And here you can see canonical variation or rather statistics, and these distinguish the different subspecies or even species of this butterfly. Case number two, my favorite, very common butterfly, even in your garden, if you are living in Europe or Asia, it's very common. We proceed with the analysis of 400 specimens from all the Palearctic region, as you can see here on this map. And we reveal that the higher UV reflectance intensities are associated generally with more hostile environments, which has got some kind of ecological and evolutionary consequences. As you can see here, UV photographs were used for analysis of specific areas on the left picture, and of this butterfly wing, of these 400 specimens, and then we correlate these with the number of environmental variables. In this case, the whole wing surface is predominantly reflecting UV light with some pigment acting as its absorbers. These pigments, no matter the name, they are some kind of pterins, whatever it is, but this deposition of pterins in wing scales and UV coloration could be indicative of the quality of these individuals. So as you can see here, we tested this hypothesis on green, white Pearis napi butterfly. As I said, this could be related to some kind of epigamic behavior and other ecological factors, which you can read in this article. Case number 3, Gonepteryx rhamni, also very common butterfly. You can see him kind of early in spring, even March or May. We analyzed more than 100 specimens of the dorsal wing of this brimstone butterfly, ranging from Western Europe to Eastern Asia. And also we employ this GMM, geometrical morphometrical methods. Landmark, as you can see here, were placed on homological features on butterfly wing. And as it has been suggested in previous studies, due to its complexity, the structural coloration, which is basically producing the UV light or the reflective of the reflection of the UV light, indicates this structural coloration indicates a whole range of mate qualities, more or less similar as the previous case in Pieris Napi. One of the possibilities of testing this hypothesis was to correlate the shape variability, what we did here, of the ultraviolet pattern with observed environmental variables of studied specimens. We observed in this case a systematic increase in relative area of ultraviolet. So in Pieris Napi, in previous example, it was the intensity of the UV reflectance, but here it was more the shape and the size of the patch of the pattern. And we observe in this case some kind of systematic increase in the relative area of this ultraviolet correlation with increasing temperature and precipitation. As I said, these findings are pointing to correlation between the shape variation of UV patterns on the forming and web environment. You can read more in these papers, what we wrote kind of recently last years. Finally, UV photography, it's not just about butterflies. Don't be scared. UV photography is used also in chemical analysis, skin analysis. This is kind of recent paper from Krautwert. Last year, he published some paper on UV image analyzing of skin analysis. Also archaeology, art examination, as you can see here, because we don't sense the UV, as I said, but the material do reflect differently the UV. So that's why it makes sense to use it in this art examination or even in archaeology. And also the aerial UV photography. On the top of the picture, this one is the fur of polar bear, and this is the UV picture of the fur of the polar bear. So you can see that the fur of polar bear is absorbing the UV light, but the snow, of course, is reflecting. So that's why there is the contrast, and you can guess in which kind of analysis you can use this. Of course, in some kind of counting of polar bears in the regions. So to conclude that, definitely, if you want to use UV photography, be sure to record right spectra, because unclear or some kind of erroneous methodology can result in unexpected or undesirable results, which could be inappropriate material used or filters or camera. There are a number of papers which are not really dealing with UV photographs, but they think that they do. Pioneering in pictures of butterfly wings said that there might be 3 criteria: completeness, the studied trait should be quantified with respect to all of these characters. Also repeatability, of course, the procedure must be repeatable. And finally, the process should be as fast as possible to available methods. I think this is not only valid for UV photographs of butterflies, but in many more studies and analyses. Please never neglect UV spectrum in your study, because it is everywhere. Even though we are unable to see UV, all the living animals, well, it's not really all, but nearly all animals are able to see some part of the UV light. And as I said before, butterflies are beautiful. these three guys said so, and you definitely know at least one of them. So please, yes, they are very beautiful. So yeah. And yeah, well, UV is unpredictable. Everything can happen in your pattern, UV pattern, and life is not simple. Neither UV. Thank you, and yeah, let's talk.